So let's work this first problem on the empirical and molecular formula worksheet. What we're trying to find is the empirical formula. And what we're given are the percents of chromium and oxygen in our molecule, chromium oxide. Now we can't do a whole lot with the percentages, so we're going to have to figure out how to make these numbers usable. Well, because we know that a percentage is a number out of 100, let's just assume that we have 100 grams of chromium oxide. That would mean that we have 68.4 grams of chromium and 31.6 grams of oxygen. Now, because chromium and oxygen have different atomic masses, we can't do a whole lot with them while they're in grams. It's difficult to compare them when they've got different atomic masses. So we're going to have to put these numbers into a unit that will allow us to compare the two. So we need to convert these numbers into moles. So we'll start with chromium. We'll look at our periodic table, and our periodic table tells us that in a mole of chromium, we have 51.99 grams. So that's the number that we're going to use. 51.99 grams per mole, which gives us a number 68.4 divided by 51.99. Here's our number there, 1.32. Let's go to oxygen now. 31.6 grams of oxygen. We want to convert to moles. If we look at our periodic table, you see that oxygen in 1 mole is 16 grams. So that's what we're going to use here, which means back to our calculator, 31.6 divided by 16. And that gives us 1.98. Now looking at these numbers, now we can compare and we can see that with chromium we came up with 1.32 and oxygen 1.98. So this means we will have fewer moles of chromium than oxygen. And now let's figure out what the ratio is. If we say chromium of 1, we need to figure out what our oxygen is going to be. And the way to do that is to figure out how many times 1.32 will go into 1.98. Come up with 1.5. So we have 1.5 oxygen atoms to 1 chromium atom, except you can't have 1.5 atoms in a molecule. So we need to get this 1.5 to a whole number. The easiest way to do that, and still keep our lowest common denominators, would be to multiply these two numbers by 2. So chromium would have a subscript of 2, and oxygen would have a subscript of 3. And that's going to be our final answer. That is the empirical formula that we're looking for of chromium oxide, given the percentages that were first presented to us.